Good morning, students. I hope all are fine at home. So let's begin with the today's class. Today we'll be starting with a new chapter, that is chapter 3, acid, bases and salts. So first of all, we should be knowing, we have a rough idea about acid, bases and salts. So acids, they have a sour taste, or we say that bases, they have a soapy touch and they are bitter in taste, and salts are the mixture of acid and bases, are formed by the combination of acid, by a reaction of acid and bases. So, but it is not possible for us to taste all the acids to identify whether it is an acid, because acids are usually corrosive in nature. So we need to understand this. So therefore we have an indicator for that purpose, to identify whether a given substance is an acid, a base or a salt. So what is an indicator? The definition says a chemical which indicates by means a sharp change color or the nature of solution. Right? So it is a chemical which is used to identify whether by showing its peculiar change in color that takes place. So therefore we can identify whether it is an acid, base or salt. Then two scientists named Lavoisier and Davy, they studied, and on the scientific lines their findings said that acids are those which are produced by the which are producing H plus ions, or which are having the H plus ion, hydrogen ion in the form of proton. Bases are those which are either metallic oxides or the hydroxide or the ammonia solution. Whereas salts, they are formed by the interaction of acid and base by replacing the hydrogen ion of the acid which is present in acid by metallic ion or non-metallic ammonium ion of the base. So that is what is salt is all about, the overview. Now in detail we'll be studying in this video about the acid. Now what are acid? The acid word is coming or derived from the Latin word acidus, which means sour. Therefore because acids are sour in taste, therefore. So what is the definition says? The definition of acid, it says that compounds which contain one or more hydrogen atoms, and when dissolved in water they will produce hydronium ions, the only positive charged ion. So this is very important, that it is having the hydrogen ion, hydrogen atom in it, but it should be, those hydrogen atoms should be producing the hydronium ions when they are dissolved, when that particular acid is dissolved in the water. Like for example HCl, we have, when dissolved in water they will be producing H plus and Cl minus ion, but H plus cannot exist independently freely, so it is the aqueous solution, so with the water it forms the hydronium ion. Now on certain bases we can classify the acids. The very first is depending on their sources, that from where we have derived the acids. Now depending on this we have organic acids and inorganic or mineral acids. Now organic acids, they are obtained from plants. As we are getting it from plants, it will be having the carbon and hydrogen atom element present in it. Whereas if we talk about inorganic or mineral acids, they will be obtained from minerals. Therefore inorganic acids are also called as mineral acid, because they are derived from minerals and they do not contain any carbon atom. Right? Exception is carbonic acid, that is H2CO3, which is a weak mineral acid. It is turning blue litmus pink and it is having the carbon in it, but still it is a mineral acid. So this is one of the exception in this case. Now if we talk about the strength, so we can say that organic acids, they are weak acids. They are not, and why they are weak? Because they are not ionizing completely in the solution form. They do not ionize completely. They are, therefore, they will be having both ions and molecules in the solution. Example, acetic acid. Whereas inorganic acids, if we talk about, it is strong acid. Why? The reason is that they ionize completely in the solution. Therefore, if they are ionizing completely, that means high concentration of hydronium ion. Example, HCl. Now, oxyacids and hydroacids are another category which is based on the elements present, the type of elements present. So, we have oxygen, hydrogen, and any other one more element is there. So, therefore, we say those acids as oxyacids. If we have hydrogen, other element, but no oxygen should not be there, so that acid is called, those category of acids are called hydroacids. Remember, for if we have hydrogen, it is not that hydrogen is there, so it will be hydroacids. Oxygen is there, so it's oxyacids. It is oxygen is present along with hydrogen and other element. It is oxyacids. Those are oxyacids. Whereas if no oxygen is there but hydrogen and other elements are there, so therefore it will be hydroacids. Now, on the second classification can be done on the basis of their basicity. So now first we have to understand what is basicity. Basicity is the number of hydronium ion produced by the ionization. After the ionization process is taking place, how the number of hydronium ion produced. So how many number of hydronium ion is produced, that tells us the basicity. And it is not the number of hydrogen atom. How many number of hydrogen atoms are present in the molecule or in the acid, that is not the basicity. It is the number of hydronium ion produced. So based on this basicity, we have three types of acids: monobasic, dibasic, tribasic. Mono, the word we have come across many times. Mono means one. That means if it is producing only one hydronium ion, then it will be monobasic. Dibasic, if it is producing two hydronium ions. So if it is producing two hydronium ions, that means it will be a two-step process, where in two steps it will be forming the salts. First will be the acid salt, because H ion is there, and the second will be the normal salt. Whereas tribasic, the word tri means three hydronium ions, so it will be a three-step process in which two acid salts will be formed and one normal salt. Whereas in monobasic, directly one normal salt will be there. Now H3PO4, as H3PO4, it is saying that three hydrogen are there, so that means it should be tribasic, but no, it is a dibasic acid, because only two replaceable hydrogen are there. The third hydrogen, which is directly attached, that is not replaceable hydrogen atom. Therefore it is an example of dibasic and not tribasic. Now concentration, the next is concentration of an acid. Now concentration of an acid, what it is, first we have to understand that the amount of acid present in a definite amount of its aqueous solution. So how much amount of acid is present, that tells the concentration. So depending on this concentration, that is the amount of acid present, we can have concentrated and dilute. If very small or no amount of water is there in the acid, then it is called concentrated acid. Whereas if far more amount of water than its own mass, that how much so much amount of water is present in the acid, then we consider it as dilute acid. Now concentration and strength, these two are totally different concepts. These are not to be mixed up, so they are not equal, they are not same. So strength is different. What is strength? Strength is the measure of concentration of hydronium ions it produces. So concentration is depending on the amount of water it is having, whereas strength is dependent on the concentration of hydronium ion it is producing, right? So strength of an acid, it is depending on two factors: degree of ionization and the concentration of hydronium ion produced, that how much hydronium ion produced, and second one is the degree. If degrees of ionization is more, definitely concentration of hydronium ion will be more, so strength will be more. So degree of ionization can be calculated by this formula: number of acid molecules ionized, that how many acid molecules are being ionized upon total number of acid molecules present in aqueous solution into 100. And if degree of ionization is denoted by this alpha sign, alpha symbol, so alpha is greater than 30%, it is a strong acid or alkali, whereas if it is less than 30%, it is a weak acid. How to? Then next is preparation. Next comes the preparation of acids. Now how we can prepare the acids? First is by simple synthesis. Synthesis means combination, hydrogen plus the non-metal, and to produce the acid. The second way is action of water on non-metallic or acidic oxide. So if we have acidic oxide plus water, so we can prepare acid. So now we have to remember that this process, this method can be used only to produce oxy acids and not hydra acids. And NO2 is called mixed or double acid anhydride, because when it combines this acidic oxide is mixed with water, it is producing two acids, that is nitrous as well as nitric acid. That is the reason it is called mixed or double acid anhydride. The third method by which we can prepare the acid is non-metal reacting with acid, with any acid to produce acid, the other acid, and water and oxide, the respective oxide. Then the next is salt plus less volatile acid. When heated, it will be forming salt and the acid. The acid formed will be more volatile. So what will be there? The displacement. Salt of more volatile acid will be replaced by less volatile. So this is less volatile as compared to HCl. So this will be replacing this, forming the more volatile acid. Right? These are the four ways by which we can prepare the acids. Now the various physical properties we talk about of acids. The first is taste. The taste is usually sour, but we do not taste them as they are corrosive in nature. The second thing, physical property to be studied is physical state. So it can be solid, it can be liquid acids as well. From amongst liquid acids, we have both volatile and non-volatile. Now what is volatile? Volatile acid means that at room temperature they just vaporize easily. So those are volatile acids, whereas non-volatile, which do not show this property. Now effect on skin, definitely being acids, they are corrosive in nature, they can cause painful burns. Then how they are changing the colors of with the indicators. So if we have a litmus paper, blue litmus paper, it will be turning into red. Methyl orange will be turning into pink. Phenolphthalein will remain colorless. So these are the color changes on the indicators in the acidic medium, right? Then the last is that they are electrolytes. They are electrolyte as they can pass conduct the electricity through it. Now comes the chemical properties. Now what are chemical properties? Chemical first is reaction with active metals, right? So with active metals, the acids react to form the salt and liberate hydrogen gas, right? But we can see that nitric acid being a very strong oxidizing agent, we do not prefer it, we do not use it for the preparation of hydrogen gas, because being a strong oxidizing agent, what happens, the hydrogen and nitric acid, they have a reaction between them, so therefore the purpose of producing hydrogen gets defeated. So therefore we do not go for nitric acid, and only manganese and magnesium, they can produce hydrogen with very dilute, that is 1% dilute acid is being produced by nitric acid. Now the next way is property is neutralization reaction, which we have already studied in class 9, that acid reacts with base to form salt and water as the only products. So now what is happening, basic oxide or basic hydroxide, they react with acid to form salt and water. Now the third chemical property is decomposition of hydrogen carbonate and carbonates. So now carbonates or bicarbonates, they react with acid to form salt, water and carbon dioxide. Gas is liberated. Then the next is decomposition of sulfides and bisulfides. Now sulfides and bisulfides, what they do is they react with acid to form salt, water and sulfur dioxide gas is being liberated. Then if acids are reacting with metal sulfides, then they will be producing salt and hydrogen sulfide gas. Now the general reactions you have to remember, as they will be used in the later chapter of acids, various acids, if you will be studying later in the class 10th. So therefore you must learn all these general reactions of the acid, how they are reacting. The last chemical property we have is reaction with chlorides and nitrates. So only few chlorides and nitrates, they can react easily with dilute sulfuric acid and dilute hydrochloric acid to form their respective chlorides or nitrates, and the salts will be formed. Whereas most of the others, chlorides and nitrates, they will be reacting with only concentrated sulfuric acid on warming it. It has to be warmed also, concentrated also, then only they will be liberating HCl or HNO3. Now this is how, these are what chemical properties are all about. So general reactions, please learn by heart from now onwards, so that it will be a help later in the chapter. Now the last is general uses of some acid, which is already been given in your books. So general uses are there in your books, table 3.2.4. So boric acid, citric acid, oxalic acid, carbonic acid, tartaric acid, acetic acid, hydrochloric acid, benzoic acid, then nitric acid, phosphoric acid, all these uses are being mentioned in your book, so you need to learn them, and kindly go through the chapter, understand it, and then the next video you will be watching of the next topic, that is the basics. I hope you all have understood. Kindly learn it and go through the chapter, and if you have any doubt, you can always come back to us and ask your doubts. Thank you.